Hello everyone, welcome to PM Networking. Hope you all are doing great. Guys, today in this video, we are going to understand advanced configuration of NAT network address translation as well as ACLs, access control list. So see, this is my scenario for today. And guys, this scenario is pre-configured, like GRE tunnel is working fine over here and these two sites are able to communicate with each other. First of all, let me make you familiar with this topology, guys, then we will move to configuration part. So as you can see, in this scenario, I have two sites. Let's say this is headquarter and this is my branch office. Let's say the headquarter is in Delhi or in Bangalore and branch office is somewhere else like in Chennai, Pune, Mumbai, anywhere. Okay, so I have two sites, two private network, and both are connected together through public network, through internet, through ISP, internet service provider, right? And as you know, two private sites cannot communicate with each other through public network. So to make connectivity between two private network through public network, we are using a technology called VPN, virtual private network. So here I am using site to site VPN, right, GRE tunnel, and my GRE is working fine. So you can say this is my virtual network, guys, between router 1 and router 2, because router 1 is my edge router for headquarter and router 2 is my edge router for branch office, right? On both routers I have created one tunnel, and see, on the tunnel interface of router number 1, the IP address which is running is 192.168.1.1, and on the tunnel interface of router 2, this is the IP address 192.168.1.2, and both IP addresses are reachable with each other through the public IP address, right? Like the public IP address on this interface is 15.1.1.1 and public IP address on this interface is 16.1.1.1, and as both public IP addresses are reachable with each other, we can form tunnel, right, with the help of these public IP addresses. So my source tunnel IP address is going to be 15.1.1.1 on router number 1, and the tunnel destination IP address is going to be 16.1.1.1, and as both are reachable with each other, tunnel will come up. In the same way, on router number 2, my tunnel source is 16.1.1.1 and tunnel destination is 15.1.1.1. So you can see tunnel is working fine here. And guys, on the tunnel interface, I am running one dynamic routing protocol to exchange private network information. Like in headquarter, I am using this subnet 10.1.1.0/24, and in the branch office, I am using this subnet 20.1.1.0/24. You know, I know there are lots of enhancement is required in this topology, like between edge router and ISP I'm using serial link, but as you know, nowadays we are not using serial link. So here we are using, you know, optical fiber in the real time in the production network. So just assume this is optical fiber, no problem at all. And if I will talk about the second problem, first problem is link between edge router and ISP. I'm using serial, but this is just a practical in GNS3, so that's why I'm using serial link over here. In the production network in real time, you are going to use fiber cable here, right? Then guys, the second issue can be you know, firewall integration. We don't have any firewall at headquarter as well as in branch office, so we need to integrate one firewall over here as well, one firewall over here as well. Okay, so this is second problem that you can work on these issues, right, to improve this network. Then third is, you can say, segmentation. You can perform segmentation over here, you can perform subnetting, you can divide the large network into a smaller network for better security, for easier management, right? We need to perform the subnetting here, like we can create VLAN on switches, and then we can differentiate the traffic, like we can create one VLAN for these servers, let's say VLAN 10, one VLAN for the users, VLAN 20, other VLAN for other department. Like this we can perform the segmentation. So segmentation is also required over here, right? So these are the weakness of this network design. Definitely in any other video I will talk about the improvement, guys, what improvement you can implement or you can do in this type of network. Okay, but today in this video we are going to understand the NAT and ACL configuration over here. Okay, so see, as I told you, tunnel is working fine, and on the tunnel interface I'm running OSPF routing protocol. And guys, we have OSPF neighborship on the tunnel interface, and through OSPF we are exchanging private network information. Like router 2 have 10 network information through OSPF, and router 1 have 20 network information through OSPF, right? But the issue over here is these user or these servers are not able to access internet. Even users in branch offices are not able to access internet because NAT is not configured on any edge router, right? So first thing that we are going to do over here is we are going to configure NAT, network address translation, so that my end user can access internet. After that, guys, my second requirement in this scenario is like you can see I have two servers in the headquarter. So my remote users, means user of my network, should be able to access this server through my private IP address, and through the tunnel my remote users are able to access the server, right? Like if you will check, PC2 is able to ping this server or not. So there is reachability, right? Means my remote users can access my server through tunnel interface through my private IP address. But my second requirement in this scenario is outside users should be able to access my server, not my server, right? Only one service on my server, let's say HTTP service, web service, or telnet service, right? So outside user should be able to access only web services, right? HTTPS on these two server, or let's say HTTP service on server 1 and telnet service or any other service on server number 2 through public IP address, through not private IP address, right? Through private IP address, outside users cannot access my server, right? So let's say on the internet, guys, there is one guy whose name is Rahul. So Rahul should be able to access HTTPS service on my server 1, which is located at my server 1 through public IP address. Okay, so we need to configure, you need to configure router number 1 in such a way so that outside user should be able to access HTTPS service on server 1 through public IP address. Okay, so this is my second configuration that we are going to do in this video. So hope it is clear, guys, what we are going to configure in this video. So first thing, ACL, access control list. And see why ACL. ACL, we are going to configure ACL for NAT as well, guys, for network address translation. For static NAT, definitely we are not going to configure NAT, sorry, access control list. But for dynamic NAT, like so that all users in my network can access internet, for that I'm going to create ACL. The second reason why I'm going to create ACL over here is actually I'm going to create multiple access control list on router number 1 and maybe on router number 2. Why? Because as I told you that outside user should be able to access HTTP services on my server. So you need to make sure that outside users are not able to ping this server, or maybe multiple services are running on this server, but outside users should be only allowed to access web services, not other services, right? Like outside users should not be able to take telnet of my server, because let's say telnet is also enabled. So I don't want to provide telnet access to outside user. Getting my point? So hope this is clear. Okay, so as I told you, GRE is already working fine, VPN is working fine, and the routing protocol is also working fine. Both sides are able to communicate with each other, but both sides users are not able to access internet. So I'm going to configure NAT, network address translation, and then I am going to provide access to my servers to outside user through public IP address. Access of not server, access of HTTP services on server. Okay, so guys, without wasting our time, let's begin. First of all, let me verify the configuration, guys. Let me show you the connectivity between side 1 and side 2. So here I have console of each devices. You can see router 1, router 2, router server 1, server 2, PC1, PC2, and ISP. So first of all, let me check IP address on PC1. Say so IP all. So we don't have any IP on PC number 1. Let me configure one IP, that is 10.1.1.10 is the IP address of PC1 submit mask is 24 and default gateway 10.1.1.1, as you can see below PC1, right? Now I am going to define IP on PC2, IP 20.1.1.10/24 and gateway is 20.1.1.1. Done. So PC1 have assigned this IP address on their interface and PC2 have assigned this IP address 20.1.1.10. Now on router number 1 or directly from PC number 2, if you will verify the connectivity like ping 10.1.1.10, which is the IP address of PC1, so you can see I am able to ping PC1. That means there is reachability between both sides, right? Both sides are able to communicate with each other. Even you can ping to server through private IP address. So ping and server IP address is 10.1.1.100. So you can see this ping is also will work. Yes, this ping is also working. That means my remote users are able to access my server through private IP address. This is why, because of router 1 and router 2 configuration, you can see so run interface tunnel 1. We have tunnel 1, I think, to verify it. So IP interface brief. Yes, you can see tunnel interface 1, and then we have the IP configuration on LAN interface, IP configuration on WAN interface. Now if you will check the running configuration of tunnel 1 interface, so run interface tunnel 1, so you can see we have only defined the tunnel source and tunnel destination over here, and after that one IP address, and OSPF is running IP OSPF 1 area 0, right? So IP OSPF neighbor, and you can see we have OSPF neighborship with 2.2.2. 2.2.2 is nothing but router ID of router number 2. Address of router 2 is 192.168.1.2, means remote tunnel IP address. Done. This neighbor is on which interface, guys? On interface tunnel 1. In the same way, we have same configuration on router number 2 as well. Here we don't have any DR and BDR. I think so we have changed the network type on tunnel interface. So run interface tunnel 1. So yes, you can see IP OSPF network point to point. Here we have set the network type point to point. That means this router will not perform any DR and BDR election on tunnel interface. Done. Then go to router number 2. So IP interface brief. Here also we have tunnel 1. So run interface, interface tunnel 1. So you can see here also we have changed the OSPF network type, the IP address 192.168.1.2, and the tunnel source is serial 2/0, tunnel destination is 15.1.1.2, and so run section OSPF. You can see the OSPF configuration. So I have set the router ID 2.2.2 here, and OSPF is enabled on two interfaces. One is on tunnel interface and one is on my LAN interface. And guys, I think so this router is sending hello message from the LAN interface as well. So you should configure LAN interface as passive interface so that this router should not forward any message of hello message from OSPF, any message of OSPF from the LAN interface. So debug IP OSPF hello. You can see, I think this router is sending hello message from LAN interface as well. Let me verify. No, it is forwarding from tunnel interface only. Hello from which interface? Yes, all. So run interface F0/0. You can see, I think so run section OSPF. Passive interface is not configured here, so it should debug IP OSPF hello. It should send hello message from, yes, it is sending hello message from fast Ethernet 0/0 also, right? And fast Ethernet 0/0 is my LAN interface. So I am going to configure passive interface, say router OSPF 1, and then passive interface fast Ethernet 0/0. Need to do same thing on router number 1 also. And after that I will move to net configuration. Router OSPF 1 and say passive interface fast Ethernet 0/0. Done. Now it will not send any message of OSPF from the LAN interface. Fine. Now guys, next thing, so run section NAT. See, NAT is not enabled. Section IP NAT. So NAT is not running there. So IP NAT statics, we can use this command as well. NAT is not configured on router number 1, router number 2. So because of this, the user and users cannot access internet. You can verify it, and for the verification, we have one loopback interface on ISP. So IP interface brief. So you can see we have one loopback on the ISP router, that is 8.8.8.8. So you can ping 8.8.8 from PC1. Let me take you to PC1 and let me ping 8.8.8.8. See, ping is not working. Why ping is not working? Because NAT is not running right on edge router, and ISP router don't have route for the private network. So ISP router will drop the reply message. Maybe edge router will forward ICMP request message to ISP router, but ISP router will drop it because ISP router will not have private network information, or maybe in real time on the interface of ISP router, ACL will be configured, right? That will be dropping all private network. Okay, so if your edge router will not perform translation and it will forward traffic to ISP router directly, then ISP router is going to drop the packet, right? So what we need to do, we need to configure NAT on edge router. So guys, so IP route, do we have any default route here? Yes, we have one default route towards ISP. On router number 2 also default route is required. So IP route. So yes, we have route, and as we have route, that's why both public IP addresses are reachable with each other, correct? So let me do one thing. Let me configure NAT, guys, here. First of all, this time I am configuring NAT so that my end users can access internet, right? Not configuring NAT to make server accessible from outside users. Getting my point? Now I am configuring NAT for my end users so that my end users can access internet. So I am going to create one access list just to match private network, right? So say access list or IP access list, IP access list standard, let's say number 10, and then I am going to say permit 10.1.1.0 0.0.255. Done. Then guys, IP NAT inside source, I'm going to say inside and match source from list number 10, right? So it is going to match source from this network 10.1.1.0, and it will match all users right in the headquarter, correct? So IP NAT inside source list 10, and I'm going to configure PAT here, port address translation. Either I can configure dynamic NAT or PAT. Both are unidirectional, means you can access the internet but internet cannot access you, and static NAT is bidirectional, means you can access the internet as well as internet can access you. So for the servers, I'm going to configure a static NAT. For the end users, like end users should be able to access internet, I'm going to configure PAT. Either you can configure dynamic NAT or PAT. Dynamic NAT is nothing but many IP address to, it is a translation from many private IP to many public IP address, or you can say to a range of public IP address. So in dynamic NAT, you will define one range of public IP address. Let's say in the range there are 3 public IP addresses, right? 15.1.1.3 to 6, 15.1.1.1 to 15.1.1.6. That means 3 users can access internet at a time. So this is problem of dynamic NAT. In the PAT, what you can achieve, PAT is many to one translation, means many private IP addresses are going to be translated into single public IP addresses, right? Because PAT is going to translate port number as well, right? IP address as well as port number. Dynamic NAT is IP translation only, port address not get translated, but in the PAT your IP address also get translated and your port number also get translated. Again, source IP and source port, right? When router 1 will send traffic to ISP, router 1 is going to translate source IP and source port. When it will receive the traffic reply message, then router will translate destination IP, destination port, right? It is going to add unique port number. Okay, so here I'm going to configure PAT so that my all users can access internet through one single public IP address. So let me say interface and serial 2/0. So whatever IP address is running on serial 2/0, right? Whatever IP address is running on serial 2/0, guys, like 15.1.1.1 is the IP address on serial 2/0. So router 1 is going to translate all private IP addresses into the single IP address which is running on serial 2/0, that is 15.1.1.1. Okay, and then say overload to PAT. Right now I am expecting that PC1 can access internet, guys. So let me take you to PC1 and say ping 8.8.8. Again you can see ping is not working. So what is the issue now? Actually we didn't define the inside and outside interface on router number 1. So let me take you to router 1 again and let me define F0/0 as inside. Say IPNet inside, this is my inside, and interface serial 2/0, say IPNet outside, this is my outside interface. Done. Now go to PC1 and let me ping 8.8.8 again. Yes, you can see this time PC1 is able to ping 8.8.8. That means my end users are able to access internet. In the same way, servers can also access internet, ping 8.8.8.8. Yes, you can see ping is working. Server 1 is able to access internet, ping 8.8.8. Yes, server 2 is also able to access internet, but router 2 can, sorry, PC2 cannot access, means users in branch offices cannot access internet because we didn't configure NAT on router number 2. So let me configure NAT on router number 2 also, guys, very quickly. So before that I need to create one access list. So say IP access list standard number 10, and I am going to say permit 20.1.1.0 0.0.0. Okay, and 0.0.255. Then IP NAT inside source list number 10 interface serial 2/0, say overload. Done. Now inside and outside interface 0/0 IP NAT inside and exit interface serial 2/0 IP NAT outside. Done. From PC number 2, let me check 8.8.8 is reachable or not. So yes, you can see now my private users in branch offices are also able to access internet. Now guys, third task, that my server should be accessible from internet, right? Only web traffic should be allowed, right? And outside users should be able to access web services on my server, right? So I need to configure R1. First of all, to provide access to your server to outside user, what we need to do, you need to configure bidirectional NAT, right? And bidirectional NAT is static NAT, means we need to configure a static NAT over here. So guys, I have 2 servers, so I need how many public IP address? I need 2 public IP addresses for 2 server, right? A static NAT is 1-to-1 translation, means one private IP address will get translated into one public IP addresses. So I have 2 servers, I need 2 public IP addresses. And as you can see, I have subnet with /29 between router 1 and ISP /29. That means how many IP addresses we have? We have total 6 number of valid IP addresses. Dot 1 is running over here, dot 2 is running over here, dot 3, dot 4, dot 5 and dot 6. I can use these public IP addresses for servers. To verify, what you can do, from router number 1 you can see, so IP interface brief on serial 2/0, guys, The IP address which is running is 15.1.1.1, and .2 is running on ISP side. Let me verify it. Ping 1.15.1.1.2. So see, ping is working. That means 2 is running on ISP side. Now I am going to configure 2 static NAT. IP NAT inside source static. This time source static, not list. So now tell me the IP address of your server, means private IP address, or here if you will put the question mark, it is asking inside local IP address, means your server IP address. My server IP address is 10.1.1.100, right? Then it is asking inside global IP address, means your public IP address, means to what IP address you want to translate this IP address. So my public IP address is 15.1.1.3, let's say. 1 is running on router number 2, 2.2 is running on ISP side, and I am using .3 for server 1. So this public IP address is the public IP address of server 1, means my outside user will access server 1 through this public IP address only. Done. Right, now I need to configure one more static NAT for server 2. So say IP NAT inside source static. IP address of your server 10.1.1.200, and the public IP address 15.1.1.4. This, right? So guys, my public IP address of server 1 is 15.1.1.3, and my public IP address for server 2 is 15.1.1.4. Right, now let me verify from the ISP, means on the ISP, as I told you, we have one loop back, right? You can see on ISP router I have one loop back 8.8.8. so just consider this is outside user, the user on internet, right? So this 8.8.8 should be able to access my server. So let me do one thing, let me ping my server. My server IP address is 10.1.1.100 and say source is 8.8.8. Will it work, guys? No, because again you are pinging to private IP address, right? And private IP addresses are not allowed on public network, means on ISP router. So you need to ping this IP address through their public IP address. So what is the public IP address of server 1? 15.1.1.3. so let me ping 15.1.1.3 and say source 8.8.8, and you can see ping is working. That means I'm able to access the server, right, through the public IP address. Okay, if you want to verify, simply what you can do, like you can enable the telnet on server 1 just to verify that I am pinging to server 1 only, right? So let me do one thing, go to server 1, and here I am going to say line VTY 024 no login, and go to now router number, sorry, again ISP router, and from ISP router say telnet 15.1.1.3, 15.1.1.3. so actually you are hitting to server 1, right, through their public IP address, and you can see, guys, you have access of server 1 only, right? So through this public IP address server 1 is reachable, right? But as I told you that outside users should not be able to telnet my server, or should not be able to ping my server. Outside users should have only HTTPS access. So how you will achieve this? You will configure the access control list on router, right? And guys, before configuring the access control list, let me show you that outside users are able to access server 2 also. Ping 15.1.1.4. so see, this IP address is also reachable, means I'm able to access server 2 as well. But this till now I have all access of server 1 and server 2, right? But I want to give only HTTPS access. So what I will do, go to router number 1, and here I am going to create access control list. Say again IP access list, this time I'm saying extended, right? Number, let's say 101. Then permit TCP host, not source is going to be any, outside user can be anyone, right? So source is any, Destination is host my server IP address. See, now again to think, we are applying access control list here and NAT is already running. So if ACL and NAT both is configured on router, then what is the order of preference between NAT and ACL on router, guys? Means router is going to check first ACL or NAT, because you are allowing any host for 15.1.1.3, right? So if it will check ACL first, then destination is going to be what, 15.1.1.3. If it will check NAT first, right, it will perform translation first and then ACL, then guys destination is going to be what, 10.1.1.100, because NAT will translate the destination, right? So always keep in mind, if I will talk about the order preference between ACL and NAT on router, so router always check first ACL, right, then NAT. So we need to define destination what here, 15.1.1.3, right? So first it will check the ACL. 15 is allowed TCP traffic, for TCP traffic only, port equal to 80. So if it is allow, then only it is going to translate, right? Let me hit enter. Now I am going to apply this ACL on serial 2/0, and before applying this ACL, one more thing I need to do here, deny IP NE NA. Rest traffic is denied. Now go to internet, means ISP, and try to ping 15.1.1.3. See, from the ISP router I am not able to ping 15.1.1.3, right? And to perform the lab, one more thing here, actually what is happening when you are pinging 15.1.1.3, what is happening? Okay, what port number I have allowed here, guys? 80. I need to allow 443, or let me allow telnet as well, just to perform the lab. So what I am going to do here, I am going to add one more entry, permit with sequence number what, do so IP access list. So we have this access list, extended IP access list 101. We have two rules here. One, with permit TCP any to this IP address equal to www, right? And I have one another rule with sequence number 20, which is denying everything else, right? So I'm going to add one rule between sequence number 10 and 20. So let's say sequence 11, and then say what, permit TCP host 15.1.1.3 23 equal to 23. So I have allow telnet traffic as well. What happened? Equal to 23. Sequence number 11, permit TCP host host any, and destination, not host here, source any, and destination host 15.1.1.3 equal to port number 23. Now go to internet router, ISP router, and let me say telnet 15.1.1.3. So you can see I am able to telnet server 1, but I am not able to ping server 1, ping 15.1.1.3. I'm not able to ping is also working from here. Let me check R1 access list here, 11 permit ping 15.1.1.3. Sorry, earlier IP address was incorrect, guys, 15.1.1.13. So actually I didn't apply this ACL on serial 2/0. So let me do one thing. Let me apply this ACL on serial 2/0 of router number 1. So as ACL is not applied, outside users are able to ping also, are able to send TCP traffic also. But once I will apply the ACL on serial 2/0, say IP access group 101 and direction in, whenever traffic will hit on this interface, it is going to check the ACL rule. Now go to internet router, ISP router, and just ping to this IP address. You can see ping is not working. Success rate is 0%, but telnet 15.1.1.3. So as telnet is allowed, you can say outside users are able to telnet server 1, but outside users are not able to ping server 1, right? So outside user now can only send HTTP traffic and telnet traffic. So I don't want to give telnet access, right? So I will remove this entry, guys. Is go to IP access list extended 101 and do so IP access list. I'm going to remove this entry. Will not provide telnet access. So say no to this. No to this. And I'm going to add one more entry here, that is permit TCP any host 15.1.1.3 equal to port number 443. So HTTP and HTTPS access are configured on router number 1, means outside user can send HTTP traffic as well as HTTPS traffic to my server 1. I need to do same configuration for server 2 also, or let's say for server 2 I want to give telnet access to outside user. Just this is an example, so that's why I'm saying telnet. But in real time, guys, in the production network, you will never provide telnet access of your internal device to outside users, right? So but this is lab purpose. Like telnet, you can configure HTTP, FTP, TFTP, any service, right? Like let's say you have some books or some PDF on the server and you want to provide access to that PDF to all outside users. You can configure FTP server, TFTP server, or you can configure the router in such a way so that it will allow HTTP traffic to outside user, or FTP traffic to outside user, or TFTP traffic to outside user, right? So let me configure one more access control list here. IP access list extended, let's say 102, and say permit TCP source any, because I don't know the source. Outside users, lots of outside users are there on internet, right? So source is any, destination 15.1.1.4, which is the IP address, public IP address of server 2, right? Destination, say host here, or if you will not define the host, say wildcard mask 0.0.0, and then equal to 23, right? Or guys, if you have configured two different access control lists, what will happen? If you have configured the two access control list, you can't apply two ACL on one interface, right? In same direction. So you need to add this entry in previous access control list. So let me say no IP access group 102. I have removed this extended 102, right? Do so IP access list. Right now I have only two ACL. This is for NAT, right? So that my all users can access internet, and these ACLs are to allow only HTTP traffics from outside to inside. Now in this ACL I'm going to add one extra entry for server 2. So say IP access list extended 101, and here where I will add this rule, I will add this rule between sequence number 11 and 20, because sequence number 20 is denying everything, right? So if you are adding one rule after this statement, after this rule, it is not going to check that rule, because here everything is matching, right? It will deny everything. So sequence number should be less than 20. So let me sequence number is 15, and here I am going to say permit TCP source any destination 15.1.1.4 4 and equal to 23 telnet. Like this you can configure any other service. Done. Now so IP access list, you can see first this router, whenever this router will receive traffic on serial 2/0 means on outside interface. See on the outside interface, so run interface serial 2/0. On this interface ACL is running, ACL is enabled, yes. So first it will not perform translation. First it will check the ACL. It will open which ACL? ACL 101. So IP access list 101, right? And how many rules are there, guys? There are 4 rules. First of all, it will check this rule, right? So when outside user, let's say 8.8.8 is when 8.8.8 is accessing server 2, right? So source IP address is going to be 8.8.8.8. Destination IP address is going to be what, guys? 15.1.1.4, right? ISP will forward to router number 1 on serial 2/0. On serial 2/0 ACL is applied. So which ACL is applied? 101. So it will check rules under 101 access control list, and there are multiple rules. First of all, it is going to check this one. So here sources any, its source is matching, right? 8.8.8 source is any, but destination is 15.1.1.3, but destination over here is 1.1.1.4. so this rule is not matching. Then it is going to check this rule, permit TCP source again any, destination 15.1.1.3. this rule is also not matching. Then it is going to check third one, but third one with sequence number 15, permit TCP any, destination 15.1.1.4, and destination over here is also 15.1.1.4. so source and destination matching, guys, in this rule. So it is going to allow the telnet traffic only, right? so so if this is ping traffic, ICMP traffic, again router 1 will drop it because it is not matching in the rule number third under the ACL 101. But if it is a telnet traffic, then rule is matching, it will allow. Getting my point? So let me show you guys again from the outside, means from the ISP. I'm going to ping 15.1.1.4. see again ping is not working, and ping telnet 15.1.1.4. so I'm able to access server 2. so password is not configured. You can say, you can either configure password here, or you can say no login. Line VTY024, say password is 123. Done. Again go to ISP router and let me do the telnet, and I'm going to say source 8.8.8. what happened? Telnet source interface loopback 1. so you can say it is asking for password is 123. I have access of server 2, right? so this is how you can configure the ACL to allow outside user for a specific service on your internal server, right? And this is how to configure NAT for internal server, guys, and how to configure NAT for my all the users. NAT configuration on ASA firewall is different from NAT configuration on router. In some video we will discuss NAT on ASA firewall as well, but I think it will be much better if we will talk about the improvement, means enhancement in this type of network, like how we should enhance the configuration of router number 1, router number 2, right? What ACL should be configured here, because in the production network you have to configure lots of access control list on your edge router, and you are here running the simple general GRE, and GRE is not secure. So you have to secure the tunnel interface, guys, because your traffic is going through public network and public network is not secure. So you need, maybe you need to configure IPsec here. You can configure IPsec to secure your tunnel, and many more configuration are there. Like you can see, authentication is not configured in OSPF. So if you are forming OSPF neighborship through tunnel, right, authentication must be configured there, right? Because again, your OSPF hello message is going through internet router, through public network, right? So authentication must be configured here. Maybe in next video or any other video we'll talk about the improvement in this type of network. Now that's all for today, guys. You can see now both sides are able to communicate with each other. Both side users are able to access internet. What happened? Why PC1 is not able to ping 8.8.8? See, guys, what is the problem? Why now PC1 is not able to ping 8.8.8? When PC1 will ping 8.8.8, source IP address 10.1, 10.10, destination 8.8.8, it will forward to router 1. Router will receive it on this interface. It will perform translation. It is going to translate the source IP address is going to be 15.1.1.1. destination will be same 8.8.8.8. router 1 will forward it to ISP this packet. When ISP will generate reply, source IP 8.8.8.8, destination IP 15.1.1.1, 15.1.1.1, and ISP will forward it to router number 1. Now you tell me, access control list is running here on this interface. Will ACL allow this traffic? No. Why? Source is any, it will ignore the source, right? See the ACL on router number 1. So IP access list, ACL, source any, host, destination 15.1.1.3. This is not 15.1.1.3, 15.1.1.1, right? Source is 15.1.1.1. So here you have to allow this tab, this IP address as well, this public IP address, because whenever my end users are going to send traffic to internet, means request to internet, when it will generate reply, right, then every time destination IP address is going to be 15.1.1.1, and you have to allow all the traffic for this destination, right? So let me add one more entry here, and let me check the OSPF neighborship as well. So IP OSPF neighbor, see we don't have even OSPF neighborship, guys. So we'll discuss about the OSPF neighborship as well, because your ACL is now dropping OSPF as well, right? So let me do one thing. First of all, IP access list extended number 101. And how many rules or a statement we have under ACL, guys? We have 4 rules, right? One is this one, this. Now I need to allow 15.1.1.1, right? 15.1.1.1 for end users. So I'm going to allow it with sequence number 19, right? Just before denying everything, I'm going to allow one IP address, that is 15.1.1.1 for all traffic. It can be ICMP, it can be web, it's HTTPS, telnet, all traffic. So I'm going to allow directly IP. So say 19, then permit IP any, no, source will be any, destination 15.1.1.1, like this, right? Now so IP access list, again we have OSPF neighborship, guys, because when router 2 will send hello message to router number 1, in that time also destination IP address is going to be what? 15.1.1.1, tunnel destination IP address on router number 2, right? So router 1 was dropping this destination IP address. Because of that, and users was not able to communicate with internet, and OSPF membership was down. So now go to PC1 and ping 8.8.8 again. This time you can see ping is working, and now you can check the OSPF membership. Again you have OSPF membership. So IP OSPF neighbor, right? And in real time you will always generate log message whenever router will drop the traffic. So let me show you that also, guys. IP access list extended number 101 and 101, and do so IP access list. So see, this is your entry. I am going to remove this entry, last statement, and we'll add again the same statement with log. Now I'm going to say 20 deny IP any log. Means generate a log whenever you are denying the, whenever you are using this rule, right? Deny any, right? Now PC1, when PC1 will ping to internet, will it generate any log? No, no, because it is not using this rule. This rule is not matched this time, right? When outside user means ISP, from the ISP, if I am going to telnet, let's say server 1, that is 15.1.1.3 IP address of server 1, will it generate log message, guys? R1, what happened? Telnet, from the ISP router, telnet 15.1.1.3, see the log message. See the log message. Why we have log message? So IP access list, because it have used this rule, and whenever it will use this rule, it will generate one log message for you, right? But if you are pinging, means if this order are using any rule from here, it will not generate any log message. Okay, so if outside users are accessing HTTP or HTTP S service on server number 1, router 1 is not going to generate any log. In the same way, when outside users are accessing telnet service on server number 2, it will not generate the log message. But if someone will try to ping your server, it is going to generate one log message, right? So from the ISP, if I will ping 15.1.1.4, it is going to generate one log message. See the log message, right? List 101 deny ICMP from 15.1.1.2 to 15.1.1.4. Okay, so guys, this was a configuration of ACL access control list and NAT. Hope this video was helpful for you. If you have learned anything from this video, guys, please hit on like button. If you have not subscribed my channel, please subscribe this channel. We'll meet soon in next video. Till then, stay safe. Bye bye. But the last thing, if you have any question, query, please let me know in the comment section. Thank you. And if you want more video like this, just type yes in the comment section. Yes means if you will type yes, I will get to know you guys want more videos like this. You want a video where where we should discuss the improvement in this type of design, in this type of scenario, right? So want more videos, just type yes in the comment section. Any other videos, let me know in the topic in the comment section, right? And if you have any question, confusion, then also let me know in the comment section. Now it's all about today. Bye bye, guys.